Hello everybody, my name's Josh. I was a computer science examiner and I was a head of computer science in UK-based schools, and now I run a tutoring business where I try and help students to get the best possible grades in computer science related courses. Now, what this series of lessons is all to do with is giving you as little as possible to remember while still being able to get those top grades. And what I do is I use my experience to condense all of the spec points down into the exam questions I've seen. So all you have to do is just write the questions, write the answers on flashcards and just go over them, and then you should be able to get those top grades. Now, this lesson is all to do with the client server and peer-to-peer model. For AQA and Cambridge International, we're also going to have a little look at the CSMA OCR on that last slide. Do not write any information down because it's not relevant to your specification. And we'll look at DNS, network hardware, client server, and go through all of that information. So very quickly, just a reminder, URL stands for Uniform Resource Locator. It's a unique address which is used to locate the IP address of a web page. And essentially what we're going to be doing with that one is, why that's there is, it means we don't have to remember IP addresses, the really, really long numbers. Human beings find much easier to remember Google, for argument's sake. And it's by having that, just makes life a lot easier for us when we're trying to use the World Wide Web. Now, the DNS is the device which allows us to convert the URL into the respective IP address. Now, it's a 5-mark question. What you need to do is go through all of the steps on this to be able to access the top marks. So client types the browser into the browser the URL. The URL is sent to the DNS, so the domain name server. The DNS looks up in a big table the matching IP address of the URL. This is then sent back to your browser, which renders the web page using HTML. So it's just that 5-step process to get those marks there. Quick little reminder of what an IP address and a MAC address is. We're going to definitely go through these in more detail, but just a quick guide on these ones if you haven't looked at these before. IP address, string of numbers that allow you to communicate on a network. MAC address, a group of hexadecimal digits which uniquely identifies your device on a network, and this is given to your device by the NIC, which is on the next slide. Now, the two of these work in combination with each other. The IP address is like the way I relate it is, if I had to send you some post, I would address it to where you are geographically, like your IP address. Okay, your IP address can change based on where you are in the world. So if you move locations, it's quite likely that your IP address will change. And the MAC address is like you, right? Your MAC address never changes because that's what's given to your device by the NIC. So the two of those in combination, the MAC address is specific to your device, and the IP address of where you're geographically located allows the data packets to get to you. Now, an A-level topic is knowing the difference between IPv4 and IPv6, which are just different versions of IP addresses. Now, when we first came up with computer networks a long time ago, it was thought that they probably didn't think that there was going to be over 4 billion different devices on the network or on the internet. So they came up with IPv4, which was 2 to the power 32, which is just over 4 billion different IP addresses. Now most people, definitely over half the world's population, is going to have is going to have some kind of device, and people, especially in Western cultures, have more than one device. So those quickly got used up. And what we've got now is IPv6, which just essentially allows us to have more and more devices. I believe it's 2 to the power 128 addresses, which is a number which I have no idea how big that is, but it's huge. And it's made up of hex digits. The NIC, which I mentioned on the previous slide, is what's called the Network Interface Controller. Every single device that needs to connect to a network needs this, and it gives your device the MAC address so that you can actually communicate on there. The switch or router, which you're connecting to, what that'll do is that'll look at what your MAC address is, and then it will assign you an IP address. So, and then the router has a table where it has the MAC addresses and the matching IP addresses, and make sure the data packets get to the correct place. The couple of other little network hardware devices, we've got wireless access point, This is what's a wireless transceiver that allows the device to connect to the internet through radio waves. So that's how we connect wirelessly. A router. Couple of things about this. Network allows us to connect our network to the internet, forwards data packets to the correct place based on the device's IP address, and gives devices IP addresses on your network. And I was just talking about that process before. Switch actually does a very, very similar job. The only difference between a switch and a router is the switch does not connect your device to the internet. The switch is when your local area network, a LAN, gets slightly larger, and the router maybe doesn't have the ability to deal with the amount of traffic going on in the local area network. So we get a switch in, connect that to a router or server, and then the switch can do the heavy lifting of moving the packets about so that the router doesn't get overrun. Now, talking about client server and peer-to-peer, the key thing with this one that they want you to know is what each device is doing on the network. Now, computers request services from the server, on a client server this is, and the server either then grants or denies this request. And really what they want to see is that you understand that the server, it's almost like a hierarchy. The server decides what we can and can't do. If you think at school, there will be certain websites that you can get onto and others that you can't. You can't just freely print off as much stuff as you want. And this is because these are governed by a web server, which decides which websites you can go onto. The print server organizes print jobs, and file servers stores files. So this is better for larger organizations, and it does ask you to justify like why, and which we're going to have a look at some advantages and disadvantages in a second. The role of computers in a peer-to-peer network, so this is where everything has an equal status, and no computer has single control over the network, and this is generally better for smaller organizations. So let's have a quick look at some of the advantages and disadvantages of the different devices on here. I was just trying to make that a bit bigger. There we go. So advantages of client server: handles a huge amount of data in comparison to peer-to-peer. So that's why I'm saying large organizations, this is great. Centralized security and updates through the server, so you just have to update it or check the security on the server and then it's all done. And you don't have to do it on individual computers. Better for large organizations, already said that, and if they need quite a lot of money because they've got to buy some expensive bits of kit like servers and more cables. Peer-to-peer, much cheaper. Don't have to spend money on specialized devices such as servers, so that's a big bonus. So that might be better for smaller organizations. Easier to manage. You don't have to spend money on a specialist team to manage the network. You might if you have to go for the client server. So generally it's easier, cheaper. So this is better for smaller organizations. So if the question gives you that in that scenario, you think smaller organization don't have as much money, justify it using the peer-to-peer network, and client server is going to be for larger organizations. Now, as I said, this is only relevant for AQA and Cambridge International. So this is a question which quite often comes up, which is talking about the CSMA. Now, this is what this is how the computers and workstations work on normally a bus topology, and we're going to do some stuff about the different topologies. But what happens here is because on a bus topology, everybody can send data technically at the same time. So what this is trying to do is this is trying to stop collisions from happening in there. Now, it can be 4 to 5 marks, this question, and I've bullet pointed each of the points so that you've got 5 potential marks that you can go for here. So what happens is your computer or workstation listens to a channel. Only when data is free is it sent. So as the channel is free, it's going to send the data. Because more than one computer is connected to it, so that's the third point, can cause a collision, as they may both send data at the same time. We've kind of already mentioned that, so it's just talking about the situation which it's trying to avoid. If a collision happens, a jamming signal is sent, and then after a random time, data is resent again. So jamming signal sent, and then after a random time, it tries to resend the data.